The Module 3 problems have been broken up into two parts. So in the first part of Module 3 review, we're going to be looking at adding, subtracting, multiplying, and dividing polynomial expressions. So number 8, we're going to look at addition. When you're adding polynomials, we're going to combine like terms. So my 2y squared, it has a like term of negative 3y squared. So 2y squared plus negative 3y squared, it's going to give us negative y squared. Then negative 8y plus 3y is going to give us negative 5y. And lastly, 4 plus negative 5 is going to give us negative 1. And this is going to be our final answer. Number 9, we're subtracting two polynomials. Anytime you're subtracting two polynomials, the first thing you want to do is distribute the negative into the second set of parentheses. So we're going to have 2x squared plus 5x minus 6, then it's going to become minus 12 plus 4x squared. Now that we've distributed the negative, we can combine like terms like we did in problem 8. So we have 2x squared plus 4x squared, which is going to give us 6x squared. 5x doesn't have a like term, so it stays plus 5x. Then we have negative 6 minus 12, which is going to become minus 18. Now we're going to take a look at multiplication. So the first type of multiplication is when we're distributing a monomial into a set of parentheses. What we're going to do is to take our term negative 2x to the 6th y and multiply it to each term in our parentheses. So every time we multiply, we're going to take the two numbers and multiply them together. But when we multiply the variables, we're going to add the exponents. So what we do is we add exponents when multiplying. So negative 2 times 9 is going to give us negative 18. X to the 6th times x to the 9th, we're going to add those exponents to get x to the 15th. And since there's nothing for the y to multiply with, it stays y. Next, we're going to take negative 2x to the 6th y and multiply it by negative 3 halves x squared y cubed. So first, we're doing a negative times a negative, which is going to give us a positive. 2 times 3 halves is going to be 3. X to the 6th times x squared is going to give us x to the 8th. And then y times y cubed is going to give us y to the 4th. Moving on to our last term, we have negative 2x to the 6th y times 7y to the 8th. So negative 2 times 7 is going to give us negative 14. There's nothing for the x to the 6th to multiply with, so it stays x to the 6th. And then y times y to the 8th is going to give us y to the 9th. And none of these are like terms, so this is going to stay our final answer. Our next type of multiplication problem is a binomial times a binomial. So what we want to do here is we want to use FOIL. So everything in the first set of parentheses is going to multiply to everything in the second set of parentheses. When we do 2x times 8, we're going to get 16x. 2x times negative 3x is going to give us negative 6x squared. Negative 7 times 8 is negative 56. And then lastly, negative 7 times negative 3x is going to give us positive 21x. Now we want to combine like terms. It's going to be important that when we combine our like terms, we still write our polynomial in descending order, which means we start with the term with the greatest exponent. And that's going to be our negative 6x squared. And it doesn't have any like terms, so we can leave it as negative 6x squared. Next, we have 16x plus 21x, which is going to give us 37x. And then lastly, our minus 56, because it doesn't have any like terms either. Okay. Next, we have 2x minus 8 squared. Something like this, we have to expand. We have to write it out. 2x minus 8 squared is 2x minus 8 times 2x minus 8. We cannot distribute that squared into the parentheses because we have subtraction going on. Once we expand it, we're then going to FOIL like we did in the previous problem. 2x times 2x is going to give us 4x squared. 2x times negative 8x is going to give us negative 16x. Negative 8 times 2x is negative 16x. And lastly, negative 8 times negative 8 is a positive 64. Negative 16x minus 16x is not going to cancel because they have the same sign. They're going to combine, so we end up with 4x squared minus 32x plus 64. Our last two problems are going to deal with division. So something like number 13, where we have our three terms in our numerator divided by a monomial, which is a single term. It means all of the terms are being multiplied together. There's no addition or subtraction. We can actually split it up into separate division problems. I'm going to split it up as negative 51 m to the 9th n over 17 m squared n plus 34 m to the 8th n to the 7th over 17 m squared n minus 17m squared n over 17m squared n. So similarly to problem 10, where we multiplied our monomial into the parentheses and we had to add the exponents, when we divide monomials, we're going to subtract the exponents. So we subtract exponents when dividing. The numbers we divide like normal, like we multiply numbers like numbers. So negative 51 over 17 is going to give us negative 3. M to the 9th over m squared is going to give us m to the 7th. And then n over n is going to end up canceling. So that's the term we get for our first problem. Then we're going to have plus 34 divided by 17 is going to be 2. M to the 8th over m squared is going to give us m to the 6th. Then n to the 7th over n is going to give us n to the 6th. For our last term, we're going to have minus, then 17 divided by 17, which is 1. And then m squared over m squared is going to cancel, and n over n is going to cancel as well. So we're just left with 1. We do still have to put something there for that third term because we did 3 different divisions. We have to have 3 terms in our final answer. So our last problem, we're going to take a look at dividing a polynomial by a binomial, where we're dividing something that's got addition or subtraction in the denominator. And I'm actually going to use synthetic division because it is the easier method and it's what you're going to be asked to do on your exam. So when I set up synthetic division, the first thing we want to put is our little half box. And inside that half box, we want to put the number we get when we solve for when x minus 2 equals 0. So we're going to add 2 to both sides, and we're going to get that x equals 2. So we're going to put 2 in our little half box. Now, across the top, we want to put the coefficients of our numerator. Our numerator starts with 1x cubed, so I'm going to start with 1. We then have to work our way down in descending order for each term. So after x cubed would come x squared, which we do not have in our numerator, so we have to put a 0. So that's for the fact that we have no x squared term. Next we have negative 9x, so I'm going to put negative 9, then our constant 14. So we always put the dashed line between our last two values, and then we put our horizontal line a little bit underneath. The first value in synthetic division always gets brought down. We now multiply that value by the number in our box, so we do 1 times 2, which is 2. It gets put underneath our next value, and then we add going down. 0 plus 2 is 2. Now we repeat the process. 2 times 2 is going to give us 4. Negative 9 plus 4 is negative 5. Negative 5 times 2 is negative 10. 14 plus negative 10 is going to give us 4. Now we can go ahead and write our answer. So the value we get on the other side of our dashed line is always our remainder. It separates the remainder from the rest of our quotient. The first value on the other side is going to be our constant. Then we work our way up in terms of x. So that means I have a 1x squared. Then we have a positive 2x. Then a negative 5. So we end up with x squared plus 2x minus 5. Then we have a remainder of 4. The sign of our remainder is going to be the operation, so we're going to put plus, and then we take our remainder 4, and we put it over what we divided by, which in this case is x minus 2. And that's how we get our quotient when we divide using synthetic division. Let me know if you have any questions over these problems for your midterm.